look at exponents and the roots. So what is exponents and roots? Well, exponents and roots, they are the operators that deals with repeated multiplication and the inverse. They are the fundamental, the exponent and the roots. Both are important in algebra and higher mathematics. It is important for you to know what do we mean by the exponent and the roots. So further on, when you will move into algebra and learning higher mathematics, you can be able to compute the actual application where they can be used in most cases. And firstly, the exponent. The exponent means how many times a number of base is multiplied by itself. When we talk about the base, we learn a decimal with a base of 10. The notation for exponent is a to the power n. And we have the term exponent, or sometimes it is regarded as the powers, a raised to the power 10 or a exponent n, where a is nothing but the base of a number and n is the exponent. Or the powers. This number system shows us that the exponent represents how many times the base can be multiplied by itself. If we have a raised to the power 3, it is equals to a times a times a. That means this represents 3 times. Therefore, the base must be multiplied by itself 3 times. Example is straightforward. If we have 5 to the power 2 raised to the power 2, then it will give us 5 times 5, which is now 25. Or 2 to the power 3, we have 2 times 2 times 2, which will now give us a value of 8. Exponent itself is straightforward. However, there are some key exponent rules. And the exponent rules are as follows. 1, we have the product rule, and we have am times an, which will have am plus n. Remember that the base is the same when we are dealing with the same base. And quotient rule. When we say product rule, we represent the multiplication sign. And in a quotient rule, we say am divided by an is equals to am minus n. Remember, we have the same base 3. If we have a power of a power, then it is represented as am over n, which now gives us am times n. Fourthly, we have the negative exponent. And if we have a to the minus n, it is equals to a over an. In a product rule example, we have 2 to the power 3 times 2 to the power 1. Then we have 3 plus 1, which will give us 2 to the 4. So we multiply 2 4 times. And in this case, we have am over an. If we have 2/3 over 2 1, then we will have 3 minus 1. So we have 2 to the power 2, and we normally multiply 2 times. That's for the quotient rule. And a power of power, if we have 2 to the power 3 and 1, we have 2 to the power 3 times 1, which will give us 2 to the power 3. And finally, if we have 2 to the minus 1, which will now gives us 1 on 2 to the 1, which gives us a half. This is basically the exponential rules. So if you like our video, you can kindly like and subscribe to support our channel. Therefore, the important thing for you to remember about the exponential is this notation: a raised to the power of a certain exponential, and this exponential is now requesting the base to multiply itself by the number of times depending on the exponential value. To summarize, this base must be a fixed whole number. If you have 2 to the power n, then you can solve, or 3 to the power n, you can solve, and this represents the base. If we have 3 to the power m times 3 to the power n, then you see that this base is the same and cannot be different. It is a way in which, if we have a large number of a same base value, we can represent with the exponential, rather than if we have 100 of these three value and we want to multiply. We can have 3 times 3 times all the way to 3 times, which have 100. This 100 can now represent 3 to the 100 exponential to make it short. And this is a number representation. We will now look at what is the roots. So roots is nothing but the inverse of exponential. And how can that be possible? So roots now becomes the inverse of the exponential, and the exponential can be the inverse of the. So the notation or the general form of the roots, or sometimes the roots, is called a radical. So a radical can sometimes also called the roots, and we can have the notation such that n equals to x is equals to a. So this is the general form or the notation of the roots. And we previously mentioned that a to the power n, which is now equivalent to the x. So this is the value of the exponential. To get the base value, we normally take the square root of what is called the radicand. And this radicand is the number inside the root. And this notation represents the root. And also, this is called the nth root of the x, which is the x is the radicand. So we will also look at the root rule, which we can summarize as the root as a fractional exponent, where we have nx will be equals to x raised to the power 1 on n. And 2, we have the product rule. In this product rule, we have x, y, n. X and y, we have square root of nx times square root of ny. Thirdly, we have the quotient rule. If we have n square root of x on y, which will give us square root of nx over square root of ny. And fourthly, we have n square root of x over m, which will give us square root of n. We have xm equals to a m over n. So these are the basic rules for the root. So the connection between the roots and the exponent, we can have n square root of x is equivalent to a, which is equals to an is equals to x. So this makes them inverse to each other. The important thing to remember is the notation or the basic structure of exponent and the root, and to calculate is quite simple. So let's look at some example that correspond to each of these rules. The first one, if we have 3 root of 8, which will give us 2, where 8 is nothing but the x is equals to 8. So in terms of Looking at the exponent, if we have 2 to the power 3, will gives us x, which will also gives us 8. Secondly, and the product rule, if we have 3, root of x is 8, and let's say y is 2, then we should have 3 on 8 multiplied by 3 on 2, which will now gives us 2 times 2 on 1/3. Now we can use the exponential rule of a to the power n times a to the power m, since they have the same base. Now we will have 2 to the power 1 plus 1/3, which will now gives us 2 1 on 1/3, which should gives us 2.5198 as our answer. Or we can say cube root of 16 will also gives us 2.5198 as our answer. So you can try out those examples by substituting a value, and you can be able to see the corresponding result. So such mathematics can be applicable to advanced mathematics. Later on, we will look at mathematics that will have some relation to exponential and the roots and the polynomials. And the exponential growth and the decay, they will become more and more important, and mostly in the field of science. So letting those mathematics is not for granted, but they can be used in many of these type of application later on. So later on, when we look at those application, you should be able to understand all these basic arithmetic before dealing with those advanced mathematics, because we will still refer to each of these equation and their rules as well.